right. Without further ado, may I turn it over to Glenn, our host, to give us a little bit more background and introduce our presenter.
Great. Thanks, Megan. Welcome, everyone. Really excited to have Mark and Julie presenting today. They'll be sharing a story which is effectively two sides of the same coin. Almost exactly a year ago, around March 10th, 11th in 2023, I'm guessing many of you remember the heartbreaking photos of the flooding on the streets in the town of Pajaro. Today, Mark and Julie will put that in historical context and focus on what is happening now in the Pajaro River flood risk management project. In my humble opinion, this is just a wonderful example of kind of a role model for engineering with nature, and in particular, how you can design in multi-benefits. A quick bio on both Julie and Mark. Julie is the Environmental Planning Section Chief for the U.S. Army Corps of Engineers, San Francisco District. She has a focus on integrating nature-based approaches into U.S. Army Corps studies, projects, operations, and actions across all business lines. She's been active in California water for at least 15 years and has a master's degree from UC Berkeley. Mark is the executive director at Pajaro Regional Flood Management Agency. He's an experienced hydrologist and flood control engineer. He has an extensive background in that area as well, was with the Santa Cruz County Department of Public Works, was also with NOAA, and has a PhD in hydrology and geomorphology from Duke University. I recently learned that they're both geomorphology geeks. So if anyone wants to ask questions about geomorphology, put those in the chat as well. Okay, so I'm going to turn it over very quickly to Mark, who will get us started. Julie will follow shortly after. As Megan said, put questions in the chat. If we can see them, we'll try and answer them along the way. But you're in for quite a treat for today's presentation. Mark, I'll turn it to you.
Thanks, Glenn, and thanks, Megan. I am going to share my screen here before I get started. Hoping everyone can see that okay at this point. And then I'm going to get you guys back on my other screen. Don't know why Zoom does that, but it minimizes all your pretty faces on my other screen when I do that. But okay, I'll have you all back now. Hi, everyone. My name is Mark Strudley from the Pajaro Regional Flood Management Agency, and I'm here teaming up with Julie to tell a bit of the story on the Pajaro River and the long-awaited flood risk reduction project with the Army Corps, slated to start later this year, actually. And I think, you know, Julie, if anyone might be touching on the groundwater aspects, maybe a little bit more than I will, but this is a story about Flood-Mar, but it's also a multi-benefit story that we're going to tell here. And so without further ado, I'm just going to get going here. Just to orient everyone where we are in the state, we're on the central coast of California, and really what we're talking about in the Pajaro River is the lower Pajaro River. It's a 12 to 1,300 square mile watershed on the central coast that has its source up in the Santa Cruz Mountains and up in San Benito County and Santa Clara County, but then funnels its way sitting between Santa Cruz and Monterey counties towards the ocean. And it is this location where the Army Corps built levees historically, and also where the city of Watsonville and the town of Pajaro sit. And so that's going to be the geographic focus of our discussion here. Really quickly, just wanted to touch on the very long history of this project. This was, you know, the flooding concern as it relates to human settlement in the lower Pajaro Valley began over 100 years ago. Those concerns have persisted for a very long time, and that's what led the Army Corps and other local agencies in studying the problem in the 30s and 40s, which led to the building of the original levee system on the Pajaro River in 1949. And so this image here shows in red the stretch of basically about 26 miles of levee system on the Pajaro River, extending from the ocean all the way up to close to where the Santa Cruz Mountains are, up near this area called Murphy's Crossing. And those levees also extend up a major tributary to the Pajaro River on the Santa Cruz County or north side of the river called Salsapuedes Creek, which wraps its way around the back of the city of Watsonville, which is on the Santa Cruz County side, and then changes names awkwardly, turns into Corlitos Creek, which heads up into the Santa Cruz Mountains. There's been flooding on both the Pajaro River and Salsapuedes Corralitos Creek historically, and so the Army Corps responded by developing these levees in the 40s. But going back to this long history, it wasn't long after their construction that they failed. They failed in 1955, they failed in 1958. All those led to Congress authorizing reconstruction and improvements to the levee system in 1966. So this is one of these legacy projects that's existed with the Corps for a very long time. It's been through decades of planning that went through the 70s, 80s. We had continual flooding as we went through this planning sequence in fits and starts. And of course, we had the March 1995 flood event, which was an eerily similar event to what happened this last year in March of 2023, which I'll get to momentarily. But that's what really re-galvanized interest from the Army Corps and the locals to pursue a comprehensive flood risk reduction project in the lower Pajaro Valley. Ultimately, we got finally through the planning process in 2019. And so this series of rapid fire progress was in stark departure to the decades-long history of the planning phase of the project. So the planning phase culminated in what's called a director's report in 2019. We were able to secure two separate Army Corps investments into the design phase in 2020 and 2021, and that led finally to a turning point in the project, pivoting out of feasibility and into design in May of 2021, which was a big, big deal. We had the federal funding to do it, and it was very promising. What we were challenged by, of course, is coming up with the local match funds to make the project happen. And what was required to do that, in part, was to look at things like Flood-Mar, to look at all the multi-benefits that the project offers, despite the fact that the congressional authorization from 1966 is still, still remains a single-purpose flood risk management objective. And so Julie and I are here to tell you a bit of the story about how we've been very creative to thread that multi-benefit picture into the calculus and implementation process. And so the project that is going to be built includes setback levees that are going to basically consist of demolishing existing levees along the Pajaro River and building new setbacks further away from the river channel. And that affords a lot of different opportunities other than just flood risk reduction. It offers habitat opportunities, it offers recreational opportunities, and it also offers additional opportunities for water to inhabit a wider floodplain and therefore percolate into groundwater more so than it does now with a very confined river corridor. Before we get, so that multi-benefit description is what came into play in getting state support for the project. So I have this slide here that I call Buffer Fund Advance, and it was kind of a three-step process to get this project moving on the local non-federal side. The buffer part was a first bill, which now is a moot point, but that was a bill that was developed before wonderful Julie Beagle joined the Army Corps and other very forward-looking individuals in the district office. We were still concerned several years ago about whether or not the Army Corps was going to participate in design. So this actually precedes some of that design investment that I talked about earlier. But we do have an authorization with the state to participate in the cost of this project. It's called the Subventions Program, for those of you that may not have heard of it before. DWR has this program where they will cost share part of the non-federal cost to a project. And what we wanted them to do at the time was provide that level of cost share in the absence of the Corps if the federal government was not willing to push the project forward into design and construction. That thankfully now is a moot point. But what we followed that with were two other bills, SB 496 and SB 489, in sequence year after year. And what those two bills did is it provided 100% cost share for the non-federal costs of the project from the state. So to date, Pajaro is the only project that has had this kind of authorization. It's singularly unique. And it's because of all these multi-benefit aspects the project offers, including Flood-Mar type groundwater recharge benefits. SB 489, the latest one, actually offers advanced funding. under that program. So instead of acting in arrears, the funding from the state would be advanced to us. That's a whole other different ball of wax that I'm happy to talk about, but I'm not going to spend a lot of time focusing on that, because all the while we're trying to get this project moving and are making serious advancements, last winter happened. So enter stage left, a whole slew of atmospheric rivers. And what ultimately happened as a result of these atmospheric rivers was 4 overbank episodes on Corlitos Creek. So you see a map here that shows a red circle up in kind of the upper left corner. That is on Corlitos Creek. There are no levees currently on Corlitos Creek, and the system overtopped its banks 4 times, 3 times in January, 1 time in March. And then again, obviously in March, the same time that Corlitos overtopped its banks, the levee broke on the Monterey County side, catastrophically flooding the town of Pajaro, just like it did in March of 1995, almost the exact date. This was March 11th in 2023. Ultimately, what happened was a lot of homes experienced flooding in the Pajaro Bay Village area of Watsonville, which is a senior living community. So it was even more challenging to deal with the flooding in that community for a variety of reasons. But you can see the mud-colored streets in the city of Watsonville. That was all the water and mud that had basically flowed through the town, trying to make its way back to the Pajaro River coming out of Corlitos Creek. And this is a very eerie image of the levee break on the Monterey County side, upstream of the town of Pajaro. That happened basically in the middle of the night, late at about 11:45-ish, just shy of midnight. So all this flooding, of course, happened in the dark, as it typically does. That's just been what tends to happen out here, and it made it that much more challenging for the residents of Pajaro. And I'm also don't have time to touch on all the human aspects, the devastation of the communities. I'm not going to touch on really much of that at all, but again, that's a whole nother hour or more of discussion and talking, so we're not going to touch on that. But the result of all this was that there were 3 levee breaks on the Monterey County side. This is one called site number 2. It's actually under Highway 1, where most of the levee was eaten away. You're looking at the outboard side or farm side of the levee. The river is actually in the background here. The water was emptying through the floodplain, flowing towards the photographer here when it was doing so earlier in 2023, trying to make its way towards the ocean, and it ate almost a whole segment of the levee away. This is a site downstream. This is the 3rd levee break site. So this is where all the water piled up on the levee down by the ocean and overtopped the levee there, trying to make its way to the ocean and shoot another 3rd 400-foot long hole through the levee system. This is a map of those 3 levee break sites, and I should have colored these dots a bit differently, but there are 3 blue dots here. One is site number 1 on the far right, which is the levee break that flooded the town of Pajaro. It's on the upstream side of everything. As the water made its way down through the floodplain, it bore down underneath Highway 1 and chewed away the levee there at site number 2, continued to flow in a westerly direction across the floodplain and overtopped the levee down at site number 3. So those repairs are almost now complete by the Army Corps, thankfully, but we've been recoiling from those ever since. This is the project that's going to be built, and there's a lot of detail in here that I don't intend you to read through necessarily, but like I said earlier, the project that's going to be built now, going back to looking towards the silver lining in the future here, that this levee project is going to get built. This is mostly constituting setback levees in the agricultural areas, and then elevating levees in the few urban corridors where we don't want to disturb businesses and residents, or as little as we possibly can with this project. The story that we want to tell you now is more about these multi-benefit aspects. And a couple of years ago, I was trying to come up with ways to quantify these multi-benefits so that we could tell the story back to the state who are supporting us, and we could tell the story to other interested entities like those of you here today. And I was talking to folks like Brian Kluwer at NOAA Fisheries to try to understand what the habitat benefits might be and how we might quantify those, particularly for fisheries, as we expand the floodplain. So he was telling me about work he was doing on the Russian River and side channel mapping and trying to come up with methods to quantify these benefits through modeling. And it was an awful lot of work and getting really challenging. Simultaneously, I was talking to people like Andy Fisher, who I've known for a long time, a researcher at UCSC, who is front and center on groundwater science and has been doing work for PV water in the Pajaro Valley for many, many years. Started talking to him about different ways we could quantify groundwater recharge. And again, this is going to require some kind of outside funding support to make any of this kind of analysis happen. And all the while I was doing this, CBEC and Jacobs Engineering and DWR approached me and said, hey, by the way, we're doing this. I'm going to skip over this slide. We're doing this in the Central Valley. We have a methodology that looks at all these benefits. And would you be interested if we could apply these to Pajaro? And I said, of course I would be. And so this is where I'm going to hand the conversation off to Julie, and she's going to give us just a real quick run through of this EcoFIP analysis that got us here and how that blended into her program at Engineering with Nature. So Julie, do you want to take it from here?
Yeah, thank you. And in addition to the human aspects and the devastation and long overdue project that is currently about to be built, which is its own talk, I would say the EcoFIP project is its own talk. And I see that many of the creators and runners of EcoFIP are on the line: Jeremy Thomas, Michael Founds. So I will just skip to the next slide as a way to talk about kind of how we integrated. So to back up for a second, Mark was describing how the state required many of these benefits to be quantified in order to get funding. And on the same side, the Army Corps has made, I would say, several leaps in the last several years, turning toward this idea that we can no longer only quantify the benefits of a project based on the cost-benefit ratio, which is part of the reason why Pajaro has been so long overdue. And this idea of engineering with nature has grown. It's a topic that many of us have been working on for a long time, and the Army Corps calls it engineering with nature. But it's this idea that you can engineer in a way that gives you those multiple benefits. If you think a little outside the box, if you use nature-based solutions, there's a way to achieve flood risk management and ecosystem restoration and equitable outcomes for communities who have been underserved, recreation, climate resilience, and all of those benefits that Mark was just talking about. And it is within the confines of this, as Mark described, a single purpose flood risk management project, which is the Pajaro Levee project, which in the past would have just been considered, we would have just considered levees, flood walls, basic gray infrastructure. I came to the Corps 3 years ago to help push this district in the direction of engineering with nature, and the idea that you can inject physical process, by using nature-based features across any project that you work on at any phase of the project. So when I first met Mark, we were already past planning. We were in a piece of the project called engineering and design right before construction. And so those levee setbacks were there were already lines on the map of where they were meant to be. Next slide, please. The San Francisco district is what's called a proving ground. This is a term that Engineering with Nature program uses to describe a district across the Army Corps that just embraces these concepts. It's a culture shift. It's a different way of looking at our projects. It's a way to say, we're interested in trying new things, both from a research perspective, an implementation perspective, and then sharing the lessons learned. And so San Francisco district is this proving ground. Next slide. And that gives us this opportunity to think about what are those multiple benefits that you can achieve if you've got levee setbacks. So the Pajaro project has levee setbacks. I will say they're not very big levee setbacks. They are on the order of 100 feet, 150 feet maybe. But there's still a lot that can be achieved in terms of critical habitat, flood resilience, and also groundwater recharge, among other things. So we saw this as an opportunity, next slide, to really inject those multiple benefits in the way the federal project was thinking about outcomes. So this is a slide that I really like from American Rivers, which talks about all the benefits of a reconnected floodplain in agricultural environment. I won't read all of them. Next slide. And there's not to mention just the habitat benefits. I think all of you know are well versed in many of those, and the groundwater benefits. There's also this sort of maintenance piece of the puzzle. When we have a levee setback and we let the water spread out, slow down, recharge, you can have less stress on the actual infrastructure. And so that's some of the messages that we're trying to target both into the core, but also outside. So to get back to EcoFIP, there are many, many people invested in this region and who have been working on it. And thankfully, Mark had connected with DWR, CBEC, and Jacobs, as he described, who had done this first pass at EcoFIP. And here's an example of what they can show through EcoFIP, which is what's the inundation potential in different parts of the river system based on how in size that river is, based on the height above river between the grade and the thalweg of the channel. And in a lot of places, this channel is really incised. And so while a levee setback is good in terms of large recurrence interval events, there's not real common reconnection between the river and the floodplain unless we do something different. So we looked at, so the EcoFIP model looked at what happens if you do lower many of the areas and you excavate. Can you find more areas where you can increase groundwater recharge, and what's the potential for that? So we saw an opportunity, next slide please, to take where the levees were set back. Oh, sorry, Mark, keep going.
No, that's okay. So these are just a couple images that show a contrast between potential recharge with no lowering of the floodplain and then moving to a scenario where you lower the floodplain. You see a lot more colors on the map, just to Julie's point, but get back to your discussion, Julie.
Yeah, thank you for that. Sorry, the top is blocked for me for some reason. Okay, so we saw this, like, it was sort of like, what's the word? Like a silver lining moment where this initial analysis had been done by EcoFIP and the connection had been made with Mark. We were at this point in the project where just like a basic Army Corps question, how are you going to build those levees? How are you going to pay for that? What's the cost of importing soil to build the levee prism? And we thought, okay, based on those real high level EcoFIP analyses, are there places where we could excavate material from inside the floodplain? So we're calling them borrow areas, but they're shaped like floodplains and side channels. And so really trying to thread the needle between saving the project money, can we use some of that material that we excavate from within those levee setbacks to build actual levee, while also achieving all the benefits that the EcoFIP model showed us, and that we understand from being out there when you see how high the existing grade is from the channel thalweg. So we started to work very, very quickly between the DWR, CBEC, Jacobs team, Mark, and my team to design, could we inject these borrow features into the design process? We were at about 60% design for Reach 6. This is on the Corralitos part of the project. And so what I'm showing here is sort of conceptual sketches, and we worked in this program called InfraWorks. After identifying the areas where we had enough space between the levee and the channel, and we looked at the EcoFIP analysis, could we design terraces, benches, or side channels in different areas that would allow us to meet the needs of the project, borrow material, and the needs that we know this channel needs in terms of groundwater recharge and all the other benefits. So we iterated with the EcoFIP team on a couple of these, and we did it very quickly. And Michael's here. I think we did it in 2 weeks. We're trying to extend that time moving forward, but it was like all hands on deck. How can we make these features the best that they can be based on the information that we have? And so if you go to the next slide, this is an output of CBEC's model showing a part of Reach 6, which is on Corralitos Creek. This is a pretty incised section of the channel. We identified this area as an area where a terrace would be appropriate, both geomorphically and from the EcoFIP model. And next slide, please. We designed kind of a basic terrace, and there were some big considerations that we had to take into account. We couldn't be within 15 feet of the levee toe. We had to have positive drainage. We had to calculate, is this the right type of material that could actually be used for the levee? And it turns out that not all of it can be used for the levee build, but some of it can. And so this is sort of an initial sketch of what that looks like, and then sort of a rendering from a different project where we're doing this, but this is the concept. And if you go to the next slide, so this comes out of CBEC's model, which shows that your activation thresholds went from the purples, which is like 4,000 CFS, which is more on the like 100-year recurrence interval, down to 100, 200, which is more of the 2 to 5. And so we're really trying to increase inundation time, duration, and then when they run that through the EcoFIP model, which is the next slide, you can see the differences in quantification of those benefits. And so we won't go into too much detail here, but basically we're looking at inundation, period, habitat for different species, and groundwater recharge. And so the numbers, I wouldn't say mean a lot right now for us to understand, but it's more. If you lower the floodplain and you allow the river to connect with it, you can quantify those benefits. If you go to the next slide, these are some photos that Michael Founds took, because one of the big questions we had around this is, and this is the case with all nature-based features, they take space, right? It's a lot. You can just build a flood wall, doesn't take up a lot of space, doesn't cut down a lot of trees. We know there's all these benefits to nature-based features, and they do require impacts to the existing environment. And so we needed to understand what are the impacts to the existing riparian habitat, and is it worth it? And in most of these cases, it really is, but I'll show you an example where we had to change course a little bit. So next slide. So we designed 3 terraces, which I showed you, but then there was also these opportunities where there was a little more room between the proposed levee, which you can sort of see on the left bank there running down the middle of your screen, it's in gray, and the active channel. So next slide, please. There was this opportunity that we thought about, could we use that space for more of a side channel to try to inject some of that heterogeneity that we know was present in the Pajaro River system before the Corps put levees in the 40s, where we know it meandered, it anastomosed, there were multi-thread in certain places. So can we kind of mimic some of that process? Again, these are borrow features, and we're shaping it like a side channel in this example. So if you go to the next slide, this is what Seebeck and team, and we all iterated on these designs, trying to create this two-part side channel that, again, and if you look at sort of the color ramp, inundates on a much more frequently, and also avoids some of that impact along the left bank of the river. So kind of trying to thread the needle between getting that borrow to build the levee and not impacting that much of the habitat, but injecting many of these processes and benefits that we know are possible. So the next slide, again, just shows some of that, the change in benefits through the EcoFIP model. I think the next slide is actually like one of the best slides. And Michael Founds, who is a local to this area, was able to take these pictures showing in this exact area where we designed that 2-part side channel. This is one of the areas that really needs that room. And so this kind of iterative process of designing these borrow areas, we learned a lot from both his on-the-ground expertise, the EcoFIP model, and kind of the iterative process that we worked on together. So to finish up, one positive news story, the next slide, about this is that overall, injecting these borrow areas into the design process, even though it was so late in the game, saved 20% of borrow costs for the Army Corps project. And so, you know, that doesn't sound like that much, but it's a cost savings. And I think it's often we hear that nature-based solutions cost more. And so that's one of the barriers for people thinking about how can you use nature-based solutions in flood projects. And in this case, I think there are these ways to sort of thread the needle and get a win-win-win, and we've shown that here. We did have to avoid some critical habitat. So the picture that you see is this beautiful cottonwood forest, single age cottonwood forest, where we had initially designed one of the borrow features and decided it's not worth it, right? We're not going to cut down all these trees for this future benefit. And so we moved it to the other side of the creek, where actually geomorphically made a lot more sense, and there was actually no riparian vegetation. So I think the iterative nature of design is really important to consider. One thing that Mark mentioned earlier is the work of Andy Fisher from UC Santa Cruz. So Mark and I and many others are part of this University of California Office of the President research grant, where Andy and his students are actually measuring groundwater recharge in this area, both ideally pre-construction and post-construction. We'll see if we're able to do that or if we need to extend that grant. But I think that offers a real opportunity to validate the EcoFIP model, to really understand the benefits that we think we're achieving from these projects and calibrate it with real on-the-ground data. We're also looking at nutrients, and students from UC Davis are looking at sort of sediment transport conditions, because one thing we don't know is sort of what happens to these types of features over time. We are working on planning, doing the same approach to the other reaches, 2, 3, 4, and 5 on Mark's map earlier. And the idea is if we can look at this as a whole system as opposed to reach by reach, and really maximize where we put these borrow/floodplain features, we think we will have more benefits. And I think the positive thing, even though, we can't excuse or make up for the, almost 100 years of neglect that this community has had, I think one thing that is positive is that construction is meant to start this year. And ideally, we've gotten through many of the hurdles that have stymied this project over the last several decades. And I feel, Mark and his leadership on this project, I think we're on the right path. So we're happy to take questions. And that's the end of our story.
Thank you, Mark and Julie. Such a compelling presentation. Go ahead and use the raise hand feature if you want to ask questions. I'll start us off with one question, but then hopefully all the questions will come from the audience. As you both mentioned, this was a long overdue project, and now that it's underway, is there like key takeaways you have on the coordination side? Because I find it so fascinating because there's a federal, state, local, there's a public-private with Seebeck and Jacobs, there's an academia, essential science link. So just, what are the high-level takeaways from that needed coordination to implement a project like this?
Yeah, I can start on that, Julie, and you can chime in as well. That's a great question. A big part of it is kind of seeing this project through a different lens, and that's what allowed us to connect a lot of important people together. So this is a levee project. It's the bread and butter of what the Army Corps does. But Julie and I have been looking at this opportunity-wise through a different lens to recognize that it offers so much more. And it's quite frankly and simply just taken a lot of conversation and coordination through, you go to conferences and you hobnob with people, or you call people up on the phone and you try to find solutions to these burning questions, and that leads you to connect to people. And once you connect to people, you can connect everyone together. And that's what has essentially happened, is that we've had the good fortune of having very forward-looking people at DWR, at the Army Corps, in the consultant community, who are all interested in actively working on these things, and are also in very strong recognition of the long overdue work that needs to be done, and that there are opportunities to grab onto other than just flood risk reduction, even though it's so principally important here. And I think it's hard to answer the question more specifically, but it's taken leadership on all those fronts as well to see that vision. And that's been the wonderful part of this.
Great. There's one question from Irina Kogan in the chat. How is the work funded?
So, Julie, do you want to take that, or do you want to talk about the Army Corps funding first, or?
So this is a civil works project. It was a general investigation study. That's what Mark mentioned, ended in 2019, and now it's in construction funding. So it's part of the president's budget, and it's kind of for the next construction period. It's large, so it's a cost share. And so Mark, maybe you can describe. So the actual levee building process is funded by a partnership between the Army Corps and the non-federal sponsor, which in this case is Pajaro. The work that we just described, though, the Seebeck, Jacobs, DWR, that was funded by DWR, that initial, and they have a lot of other efforts going on, piloting EcoFIP in different parts of the state. And it's really amazing work that we were able to, through that coordination that Mark described, sort of create this partnership really early on. We are continuing that. So the Army Corps is continuing to pay for the next set of reaches to use that model and that expertise. So moving forward, the UCOP project that's funded by University of California, and our projects are we're sort of the recipient. We're not getting money from that. It's really sort of a parallel process.
Yeah, so a huge amount of appreciation goes out to folks like Jenny Marr and Cam Yar who saw the potential here and who graciously offered that technical assistance to us through EcoFIP. And now that technical assistance is changing hands in the partnership from DWR at the state to Engineering with Nature, like Julie was talking about as we move forward. This is a $600 million project, and approximately 65% of it is getting covered by the federal government under our Army Corps authorization. And the remaining 35% under those bills that were signed the past couple of years is coming from the state, from DWR under their subventions program.
Great, thank you. Looks like we have a question from Daniel from Sustainable Conservation.
Yeah, great presentation. Always learn more, and great to see the progress you guys are making. It actually relates to my colleague's question in the chat here, which was, as a multi-benefit project, the benefits are clearly laid out with the CBEC work. I'm curious what the landowners whose land is going to be retired or repurposed, if they view that as a benefit because of repeated flooding, or they see it as a loss, and how the communication with the landowners has been conducted. Are those willing folks, or has it been these are the best places, and how do you approach the landowners?
Yeah, so Julie mentioned that the setbacks here are not gargantuan. They're not. They're mostly 100 feet. There's a couple places where they're set back up to 225, maybe even 300 feet marginally in a couple places. That 100-foot setback came from an uncodified kind of understanding between that predates my experience with the project, between local agencies and the agricultural community. It was called the 100 for 100 plan. It was 100 feet of setback for 100-year level protection. And that's kind of the understanding that was developed a couple decades ago and has kind of been carried forward into the design and implementation now. Because the project is overdue, I think the agricultural community, who has at times in the past pushed back on the acquisition aspects of this project, in large part my understanding is that they're very supportive because they know this project needs to happen, and we've flooded way too many times. And I think they kind of reluctantly understand that, hey, I would rather not give up any land, obviously, but I understand that this is good for the community. It's actually good for my farm because I have losses every time I flood. Will we run into landowners when it comes time for acquisition that will push back? Sure, I'm sure we will. I'm sure there are some landowners and farmers out here who weren't around during those conversations a couple decades ago with the 100 for 100 plan. But I think for the most part, the community is very, very supportive.
Excellent. And I just want to shout out Michael Founts is on the call as well. He's answering some of the questions in the chat. Cam Yar is on the call as well. So there's a question from Ben Scandella. I'm just going to recommend people come off mute and ask their question. And maybe, Michael, if you want to expand on the response. Ben?
Yeah, thanks. I was curious about the estimates of increased recharge when the borrow was taken from the additional stream bank side channels. Did those increased recharge estimates just include the additional inundation time in that additional area, or did they also account for potential increased stream bed conductance through a thinner stream bed low permeability layer, or just a thinner one, or also potentially digging into less resistive, more highly conductive materials?
Yeah,
Great.
that's a great question. And Michael should answer the question, but I will just say that right now this is very high level, and so he's answered it's just based on inundation times, but we are hoping to get more specific data of actual conductivity in the channel. But right now it's very high level all of this.
Thanks.
Most of the area where those setbacks are, the depth to the water table is pretty high in those locations. So for the most part, you're not conducting. So the recharge is primarily limited by the floodplain soils in those areas. So that's what we've represented. But as Julie mentioned, as more work becomes available, like the seepage rates that Andy Fisher is calculating, we can integrate those seepage rates or whatever value, whatever input is useful from groundwater models or other information.
And I know right now that Andy's doing like differential gauging. I think he's aspiring to run some totem or other subsurface analysis to look at the architecture. And like Michael said and Julie said, we're hoping that as we set these levees back, we're going to expose old floodplain soils beneath them, which would presumably limit recharge. But as Julie and her team develop these lowered features in there, hopefully we'll be able to remove some of those materials that are going to restrict that recharge and open up some of these architectural windows into older channel deposits that are lower down.
Great, thanks. I think the next question is from Chris Hunn. If you want to come off mute and ask your question.
Sure. Hi, Chris Young, State Water Board. Just wondering how you have considered water quality benefits and are concerned. What were some of the key concerns or key benefits in this project, especially in relation to the nature-based solution features? Could be something related to like turbidity or temperature or the ecology or nutrient loads.
Yeah, I mean, so this project has gone through its review, and then we are doing a NEPA supplement for these borrow features with the Water Board, NIMS, and U.S. Fish and Wildlife Service. The agencies so far are very supportive of reintroducing physical process into the landscape as a and that's the goal here, right? Like there's this channel for the most part in this reach has sort of a single line of riparian trees, mostly non-native, kind of hanging over the edge. And so the idea here is this maybe ideally short-term impact with to water quality. I really hope not. And I think most of this construction will be done from the land side. But then in the long term, having a wider riparian forest with more successional patterns can buffer stormwater and runoff from agricultural fields. So net, I think we aren't really dealing with water quality issues in this design, but I think from other work of other types of floodplain benches that I've done in the past, kind of that buffer effect has been one of the biggest benefits in agricultural areas, that it actually slows the runoff from getting into the actual stream.
And this is a bit of an experiment and an opportunity here, right? So we have some partnership on the UCOP team from CSU Monterey Bay who are specifically looking at water quality indicators. We're also hoping that the complexity that Julie and her team ends up adding to these borrow areas offers a lot more opportunity for nutrient cycling and biogeochemical pathways that have kind of been restricted because there's very little floodplain and floodplain processing going on right now. So we have invited CDFW and the regional board to participate in these design aspects moving forward. We're a little late for them to join in the party on Reach 6, but as we move into these other segments of the project, we want to maximize as much multi-benefit as we can. There's going to be trade-offs, but I think there's opportunities here for better water quality and certainly sediment storage. I think, there's a TMDL for sediment on the Pajaro, and hopefully this extra space will alleviate some of that concern as well.
Thank you.
Gordon, do you want to come off mute and ask your question?
Yeah, it sort of has been addressed a little bit by Michael and Mark, and I'm excited to hear that you guys are planning to do some TTEM work in the area, but maybe you could speak a little bit more to how you're going to come up with these characterizations of the recharge potential using some additional soil texture or geophysical data or whatever you're going to collect.
That is almost a question ready-made for Andy Fisher, and I don't know if he's on the call. I know he sometimes is, but he's the guy that has the strategy developed for how we're going to go about quantifying the recharge benefits. So I don't know that I can answer any more than I've already answered because it's not my area of expertise. I don't know, Michael, if you have anything else, or Julie, that you want to add.
I would say
I think
everything.
Andy should come and do a talk here when
Yeah.
on his research.
I mean, this talk really begs for a part 2. I gotta say.
Yeah, I think Andy's mainly expressed more interest in geophysical studies and additional work. I don't know that it's in progress yet. So I think there's some conversations to be had with other people in the state that are working on those efforts.
Cool, thanks.
Thanks for raising your hand and the questions in chat. Go ahead and ask your question. Tom, can you hear us?
Oh, I'm sorry, I didn't hear you.
Please go ahead.
Tom Bilioni. The setback, is it measured from the Tallveg or from the bank full level, or how wide apart are the levees?
It's measured from the levee crest. So wherever it's kind of like your stud wall. It's 16 on center. This is 100 feet on center. So it doesn't really matter where you measure it from. Just imagine the levee crest as a line and moving it 100 feet into the farms.
So how wide are the levees apart?
Currently, it depends on where you are. So on the Pajaro River, I believe they're around somewhere between 200 and 300 feet apart, maybe a little more in a couple areas. So it's not tremendously wide.
Yeah, never less, just it could be more. Okay.
Yes, right.
Was AEM data available for any of the subsurface, thinking as far as permeability benefits or groundwater recharge benefits?
I don't think so, Michael. I don't think we have any AEM data.
Yeah, there's pretty limited cross sections in the area, and the airborne AEM is pretty coarse for what we would need to do, and that's why people like Andy Fisher, who want to get kind of a deeper 3D picture of the subsurface, are looking into things like TOTEM, which would give you kind of a more fine resolution where you need it to see if there's kind of layers of clay or other materials that would really impact water percolating deeper into the ground.
And I don't think there's probably less of that information out here too, because notions of like on-farm recharge out here are far less possible, because the crops out here, unlike those in the Central Valley, like rice paddies and almond orchards, you can't flood these fields. These are berry crops. These are in lower quantities now, but even apple orchards aren't tremendously amenable to on-farm recharge. So we don't have those widely distributed data sets like I think some other places have.
Thank you.
Camiar.
Julie and Mark, great presentation. I'm really pleased that we're now seem to be turning the corner from talking about Flood-Mar concepts to its application. And I think that's going to really help increase the momentum and interest in the work of the network and all the partners. Julie, I really appreciate how toward the end of your talk, you mentioned that there are cost savings and noted that there is some general perception that nature-based solutions will call more traditional approaches. I'm wondering, in the analysis that certainly the Corps does, and for this project, are we or can we use kind of the total life cycle cost analysis so that it really helps demonstrate how nature-based solutions, often their attributes present themselves over time, in particular because they don't create unintended adverse consequences?
Yeah, I think that's a great question. And for this project in particular, we're trying to just build the project now. We're not trying to go back. So, the ship sailed on Pajaro. Like, it took way too long. There's construction funding, so we're just focused on making it the best project it can be moving forward. And I think these examples, when nature-based features save money or cost less, like, I'm keeping them all in my pocket and trying to share that as much as possible. We have another example on the Upper Guadalupe River in San Jose, where we're in the planning phase still, and there was a bypass channel that was authorized previously, and we have demonstrated that if you kind of do a similar concept here, not for borrow, but actual for flood risk management, and create a large bench feature with swales, you can also save a lot of money. And so I think we're getting there with showing these examples of how they can save money. But I think your point about the entire cost, like the lifetime cost, is something that I've seen a lot of studies around. I think we still have some work to do to get there. I welcome continuing that conversation, because I think it's huge in terms of, and then the last thing I was going to say is, and maybe Mark, you were going to talk about this, is we're really trying to tie this to O&M so that the MARC doesn't get left at the end of the day with an unmanageable channel. And so that's one of we have another project that we're working on together to try to get resource agencies and the people who write O&M manuals in the same room to understand kind of how O&M manuals need to change in order to make them more feasible for people.
We're going to be on the hook to O&M this thing for its life at PRFMA. And so we're hoping that a lot of these features can be somewhat self-sustaining, and that there are trade-offs in terms of, you know, the O&M that we need to do inside the channel for capacity and flood conveyance, that there are features in there that will allow us a lighter touch. We're still going to have to touch it, but hopefully it's going to allow a bit of a lighter touch through those complex features that maybe some of them are open standing water, and that adds a different kind of habitat and groundwater recharge value than, you know, a plain riparian forest right along the channel margin. You know, the other thing to mention here is that this situation is plenty complicated, because we're going to have to continue to interface, and gladly do so, with PV water, because really we are hoping that there will be benefits paid to the groundwater basin, which is really not our responsibility. It's PV waters. And so we know Brian Lockwood and his crew very, very well. We speak with them very frequently. We continue to, you know, partner with them and whatever data sharing we can do to support their groundwater basin plan, and how these potential extra recharge elements add to their sustainability plan. I think that's just a good story to tell, and we're happy to be right along there with PV Water to help them tell that.
Thank you.
Great. It looks like we have one last question from James Carney. James, are you there?
Oh, yeah, thanks. My question got answered in the chat. I was just looking for a link. Appreciate it.
Okay, great, thanks. We're now running up against time. I've really appreciated the level of detail and the wide range of questions. Julie and Mark, any closing comments from you both?
You know, I'll just say, you know, again, thanks to Megan and you, Glenn, and DWR and the Flood-Mar crew. I mean, you're a huge part of not just inviting us here, obviously, but making this happen. This really was a partnership at all levels of government to make this happen. And the support we got from DWR from this just cannot be understated. And we really, really appreciate that. And we are really excited about building this project and quantifying these benefits and continuing to tell that story.
I can't say it better than that, but yeah, the team at CBEC and Jacobs and DWR, I mean, this was a huge partnership of passionate people, and I think I'm just grateful to be part of that community. And so thanks for having us here.
Well, excellent presentation from you both. Megan, anything to close us out? Or
That's it. Thanks, everyone. The link in the chat for where the recording from today will be shared, and probably by next week. Have a great rest of the day, rest of the week, everyone. Take care.
Thank you, everyone.
Thanks, everyone.
Bye-bye. Thank you.